Today we are going to deal with P block elements. Let us first begin with the 15 group elements. Fifteen group elements are nitrogen, phosphorus, arsenic, antimony and bismuth. These elements together are collectively called as nitrogen family. Why? Because nitrogen is head of the family, it is the first member of the family. These are together called as nicogens also. Nicogens, why? Because these elements, in the absence of oxygen, molecular nitrogen has a property to choke, to stifle, that means to suffocate. So their compounds are also called as nicomides. These elements, electronic configuration, if we look on, they all are having 5 electrons in the last orbit. To become stable, these elements require 3 electrons to become stable. They are having ns2 np3 electronic configuration. All these require 3 electrons to become stable. These elements are useful as a fertilizer, like nitrogenous fertilizer, ammonium sulfates, basic calcium nitrates can be formed. Nitrogenous fertilizer can be formed by ammonia and carbon dioxide to form urea. Ammonium sulfate can be formed from ammonia and water, whereas ammonia, water combines to form ammonium hydroxide. Ammonium hydroxide again treated with carbon dioxide to form ammonium carbonate. This ammonium carbonate is treated with calcium sulfate to form ammonium sulfate. So this way these two fertilizers are formed. Also one more compound is calcium nitrate. Calcium nitrate can be formed by treating with nitric acid. So one more compound is calcium cyanamide. This we can prepare by calcium carbide and nitrogen at a particular temperature called 850 to 1000 degree centigrade. This calcium nitride is again treated with water. This calcium nitride cyanide is altogether called as a nitrolium. Next is phosphatic fertilizers. Here calcium phosphate treated with sulfuric acid to form phosphates of lime. Next is phosphatic slag or Thomas slag can be used. Phosphorus treated with oxygen to form phosphorus pentoxide. So after these fertilizers, let us look on to one more fertilizer called as ammoniated sulfur phosphate. This can be prepared by spraying ammoniated solution, ammonia, water on superphosphates. These are mixed at a particular percentage, like ammonium nitrate at 65%, ammonia at 21.7%, water at 13.27%. These are all sprayed on superphosphate to form ammoniated superphosphate. Next, let us look on to its metallic character. Metallic character is nothing but the electropositive character. As we go down the group, atomic size increases. As atomic size increases, these elements are able to lose electrons easily, as their nucleus is very far from the last orbit. So the last electron of the last orbit, therefore they are able to lose electron easily. As they are able to lose electron easily means electropositive character increases. Therefore metallic character increases as we go down the group. So therefore we can see nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids. They can act as metal and non-metal depending upon what kind of metal is coming to it. And bismuth acts as a metal. Let us look on to its physical state. Nitrogen is first element after hydrogen to be diatomic gas in normal form. All other elements in the group are normally solids. So only nitrogen is in gaseous state, rest all are in solid state. Next, atomicity. What is atomicity? Atomicity is nothing but the number of atoms produced on separation, we can say. So for example, all these noble gases, if you consider, these are all monoatomic. Only one kind of atom is there in the gas. But if you consider dinitrogen, dioxygen, N2, O2, H2, these are having 2 atoms. So their atomicity is 2. If the 3 atoms are being given, then it is called as triatomic. Their atomicity is 3. So triatomic molecules give out 3 atoms. Therefore it is Atomicity is 3. So nitrogen is a diatomic, always it combines with one more nitrogen to become stable. Nitrogen, just now we studied, it is having 5 electrons in its last orbit. It will share 3 electrons with the other nitrogen by forming a triple bond, where the rest all family members are tetraatomic. They combine with 4 atoms to become stable. Next, what we have to study about their metallic and boiling point. As we go down the group, what happens here? Atomic size increases. As atomic size increases, van der Waals force also increases. Therefore, melting point increases as we go down the group. Melting point increases from nitrogen to arsenic. Boiling point increases regularly on moving down the group. Next, what we have to study is the density. Density is mass by volume. As we go down the group, atomic mass increases. As atomic mass increases, the density is mass by volume. The density also increases as we go down the group. Next, what we have to study is atomic radii. As we go down the group, atomic number increases. Atomic number increases, atomic radii also increases. Next, what we have to study is covalent radii. Covalent radius increases as we move down the group because the atomic size increases. Therefore, the covalent radii increases. Next, what we have to study is about the allotropic forms. All these elements are having different allotropic forms. Nitrogen has 2, phosphorus has about 4, arsenic has about 3, antimony also has 3. So, different forms are called as physical forms they are having. Next, what we have to study is about oxidation state. Here, oxidation state varies as we go down the group. Why? Because metallic character increases. As metallic character increases, we studied all these elements require 3 electrons to become stable. 3 electron they require means oxidation state must be -3. But as we are going down the group, atomic size increases. Therefore, gaining character, they are less able to gain rather than lose and become stable. Therefore, they are having +3, +5 oxidation state as we go down. But bismuth is having +3 oxidation state. It is more stable with +3 than +5. Why? Because as we go down, inert pair effect increases. Due to increase in inert pair effect, increase in unit pair effect is nothing but ns electrons. Ns electrons are more attracted towards the nucleus. As they are more attracted toward the nucleus, they do not take part in chemical reaction and they don't lose. Because of that, the oxidation state of bismuth is +3 rather than +5. Next, what we have to study is ionization energy, and ionization energy decreases as we go down the group. What decreases means they are able to lose electron easily as atomic size increases. Ionization enthalpy also decreases. Next is electronegativity. As ionization enthalpy is decreasing, electronegativity decreases. Next is catenation property. Compared to 14 group, here 15 group catenation property is little weak compared to 14 group. Reactivity. These elements is highly unreactive. Nitrogen is highly unreactive. How much unreactive it is compared to noble gases? That much it is unreactive, it is said, because it is having triple bond. To break triple bond is very difficult, whereas phosphorus is very reactive. It is very reactive and therefore it is kept under water. It is also having a property to glow, so it is called as phosphorus. It forms a multiple bond it forms. Why? Because nitrogen atomic number is 7, electronic configuration is 1s2, 2s2, 2p3. That means it is having 5 electron in its last orbit. 2p, after 2p we do not have 2d available. Therefore, nitrogen can form only p-pi bonding, whereas rest all can form p-pi d-pi bonding. This can be an anomalous behavior of nitrogen, that it forms p-pi multiple bonds, whereas other form p-pi d-pi multiple bonds due to availability of d orbit. And compounds of nitrogen we have hydrides. This is the order of formation of hydrides. Then we have to study their formation, stability, basic character, solubility, their bond angle, then the order of hydrides, reducing character, covalent character, the poisonous character. One by one we are studying all this. Next is preparation of hydrides. First preparation is of ammonia. Ammonium salt are mixed with metal oxides to form ammonia. One more is with ammonium chloride and calcium hydroxide. By any nitrates and water forms ammonia. One more preparation, a large scale, is by Haber's process. Next is phosphine, preparation of phosphine. We have from any metal phosphide and water gives phosphine. Next, other hydrates we have to study, like zinc metal gives zinc chloride. Then we have to study halides. Halides, when these metals combine, 15 group elements combine with halogen, they form halides. Then hydrolysis, on mixing with water, they break, molecules break. So the process is called as hydrolysis. So this is the order of hydrolysis: bismuth greater than antimony, then arsenic, then phosphorus, then nitrogen. Next, what we have to study is pentahalides. Nitrogen cannot form pentahalides. Why? Because it is having the absence of d orbital. It is not having vacant d orbital. Therefore, it cannot form pentahalides. Whereas rest all elements can form pentahalides. Next, formation of oxide. It forms M2O3, M2O5 kind of oxides. Then we have their preparation. Property is colorless, they are fairly unreactive, pleasing odor, they are having sweet to taste, supports combustion. One more preparation common method is from sodium nitrite, ferrous sulfate, sulfuric acid. Lab method is, commercial method is from nitrogen and oxygen. Then lab method is from copper and dilute nitric acid. One more method is by Ostwald process. Let us look on to its properties. Colorless, paramagnetic, slightly toxic gas, blue in liquid state. It is combustible and supports combustion. It is a neutral. It is having its uses like manufacture of nitric acid for detection of oxygen, for manufacture of sulfuric acid. It is having a resonance, two resonance structure it has. Then one more compound we have to study called as nitrogen dioxide. Its preparation we should study by nitric oxide, by lead nitrite, by copper and concentrated nitric acid. Its properties: it is highly toxic, paramagnetic, reddish brown gas with choking odor, acidic in nature. Its reaction chemical properties: how it reacts with water. It reacts with water to form nitric acid. HNO3 is formed. It is combustible, supports combustion on burning. It is having a 4 resonance structures. Then we have its preparation. Then its structure. Still it is under a study. Next compound is dinitrogen pentaoxide. Here its preparation we have nitric acid, then phosphorus pentaoxide. It is a common method. Then silver nitrite and chlorine with 90 degrees centigrade. Then its properties: colorless, crystalline solid. It sublimes. It is anhydride of nitric acid. Then its uses: it is powerful oxidizing agent. Its structure we need to study its ionic structure by X-ray method. It is also called nitronium nitrite. The next compound is phosphorus trioxide. White phosphorus is treated with limited oxygen to form phosphorus oxide. Its properties: white oxide, white solid, it is white like a wax, garlic odor, highly poisonous. Phosphorus pentaoxide, next compound what we have to study. With the help of phosphorus and excess of air, we can form phosphorus pentaoxide, which is white crystalline. It's a solid, crystalline solid, smells like a garlic. It sublimes on heating. It is a powerful dehydrating agent. Let us look on to its structure. Now we have to study its oxides of nitrogen and phosphorus with their oxidation state and their basicity. Basicity we can study with the help of structure. How many pH groups are formed? pH bonds are formed, those many will be its basicity. Preparation of nitrogen. We have a different methods to prepare nitrogen, from ammonia and chlorine, from ammonium dichromate, from urea, also from sodium azide. In a large scale we can prepare by Lindlar's process. Atmospheric air is compressed and then released into a bigger area when liquid air is obtained, which is mainly nitrogen and oxygen. These two are separated later by fractional distillation. We should know its properties. It is colorless, odorless, tasteless, slightly lighter than the air, slightly soluble in water, non-poisonous gas. It combines with the metal and non-metal to form number of compounds. Its uses is concentration of oxygen in air and make combustion less rapid to create inert atmosphere in the preparation of ammonia, nitric acid, calcium cyanide. Next, what compound we have to study is ammonia. We have its preparation lab method. We have with ammonium chloride, calcium hydroxide. One more method is by Haber's process with the help of nitrogen and hydrogen in presence of iron as a catalyst and molybdenum as a promoter with temperature about 700 Kelvin and 200 atmosphere. Other catalysts also can be used if the iron is not available. Next is cyanamide process. To prepare nitrolim, we require calcium carbide and nitrogen. One more is Spock's process. Aluminium nitride, aluminium nitrogen and water is added to form aluminum hydroxide and ammonia. Its properties: it is colorless gas, its pungent odor brings tears into eyes, collected by downward displacement of air. Therefore, it is collected by downward displacement of air. Extremely soluble in water due to hydrogen bonding. It is a strong Lewis acid. Ammonia is dried over any metal oxide, but calcium oxide is cheaper. It is largely used. When passed through alkaline solution of Nessler's reagent, a brown colored complex known as Millen base is formed. So these were all the properties of ammonia. Next compound what we have to study is nitric acid, also called as aqua fortis. Here are its preparation: nitrogen with the help of nitrogen oxygen, by nitric oxide and oxygen, by nitrogen dioxide and water and oxygen. One more method is by Oswald process. Here it carries out in 3 steps: ammonia with water in the presence of a platinum cause at 800 degrees centigrade. It is heated to form nitric oxide. This nitric oxide is treated with oxygen to form nitrogen dioxide. This nitrogen dioxide is treated with water and oxygen to form nitric acid. One more property of this is it is colorless, pungent, liquid, usually available at about 68% and 15.7 as a concentration. It is yellow. Aqueous solution is yellow due to small concentration of nitrogen dioxide. It is fuming nitric acid. It is nitric acid plus nitrogen dioxide, called as fuming nitric acid. Chemical properties: it is an acid. It is an oxidizing agent. How it reacts with water, how it reacts with hydronium ion. Next what we have to study is oxidation of non-metals. Acids are formed due to oxidation of non-metals. Sulfur reacts with water in presence of oxygen to form sulfuric acid. Carbon reacts with water with nascent oxygen, it forms carbonic acid, whereas phosphorus combined with water and oxygen forms phosphoric acid, whereas iodine forms iodic acid. Arsenic with water and oxygen form arsenic acid, whereas stannic acid, that is tin, combines with water and nascent oxygen to form metastannic acid, whereas selenium forms selenous and tellurium forms tellurous acid. Oxidation of compounds are there when it combines with oxygen. It gives hydrogen sulfate, sulfur, bromides, iron sulfates. Action of nitric acid on metal. Here this is Armstrong theory. The metal first displaces nascent hydrogen from acid, which further reacts with acid to give secondary reaction. Here is the reaction. Primary, it forms metal nitrides. In secondary, it forms nitrogen dioxide, nitric acid, nitrogen, ammonia is formed in secondary reaction. Factors affecting the secondary reaction: nature of metal, concentrated acid, temperature, presence of impurities. We need to know one by one. We are studying. Metal, when reacts with cold and dilute nitric acid, forms zinc nitrate, whereas with the concentrated it can form nitric oxide. Copper, with dilute it can form nitric oxide, whereas with concentrated it can form nitrogen dioxide. So there are different reactions occurring with concentrated and dilute nitric acids. Metals like magnesium and manganese give hydrogen with dilute nitric acid. So, nitric acid treating with magnesium and manganese. Metals like iron, chromium, nickel, aluminium, or cobalt become inactive or passive due to stable oxide layer. Oxide layer is formed on that, because due to that it becomes passive. One more what we have to study is about aqua regia. Aqua regia is nothing but one part of nitric acid and 3 part of HCl forms aqua regia. It reacts with gold and silver. It is used for cleaning the native metals. Structure of nitric acid, we have it is having 2 resonance structure. Next compound is nitrous acid. Nitrous acid can be prepared from barium nitride treated with sulfate, hydrogen sulfide to form barium sulfate. Sodium nitrate reacts with hydrogen sulfate to form sodium sulfate. Next, what we have to study is about their properties. Slightly bluish in color, it is in solution, maybe due to anhydride N2O3, it is very unstable. Then what we have to study is about the decomposition. It separates into nitric oxide and water. Action of heat, it is giving out nitric oxide and nitrogen dioxide. Reducing nature, oxidizing nature. Reaction with ammonia we have to study. With ammonia, it forms nitrogen. Formation of disonium salts and its uses. It is used in manufacture of azodize. It is having 2 resonance structure. It is a tautomeric mixture. Next compound what we have to study is about phosphorus and its occurrence. It occurs in combination only as phosphates. Phosphorite, chloropatite, fluorapatite, phosphoproteins of brain, bones, teeth, milk, egg, nervous tissues of animals and plants. You can find its occurrence. Manufacturing, how to prepare it. Calcium phosphate is treated with silicon oxide to form calcium silicates and phosphorus pentoxide is formed. Next is purification by melting under acidified solution of potassium dichromate the impurities of oxides and it is again redistilled. Its properties are it is colorless. On standing acquires pale lemon color due to formation of red phosphorus on the surface. It is therefore called as yellow phosphorus due to poisonous nature. The jaw bones are decayed and a disease known as jaw is formed. Allotropic forms of phosphorus and their preparation. They are having about 4 allotropic forms and they have their preparations. Red phosphorus can be prepared by heating yellow phosphorus, whereas violet phosphorus can be prepared by crystallizing white phosphorus. Scarlet phosphorus can be prepared by exposing the solution of red phosphorus in potassium tribromide to the light. And black phosphorus can be prepared by heating white phosphorus. There are few of its chemical properties. Phosphorus is having few chemical properties with a non-metal. It reacts with metal, it reacts with other compounds like sodium hydroxide and water. It reacts to form different compounds. Then it is having its uses. It is used for preparation of matchbox side. The side contains about red phosphorus and sand and glue. On the tip of that matchstick, on the stick, it consists of red phosphorus oxidizing agent, glass powder and chalk of friction plus glue. One more new compound what we have to study is about phosphine. Phosphine can be prepared by calcium phosphate water. Phosphine is formed. The other one is by decomposition of H3PO3. Then we have to study phosphoric acid's properties. Colorless, highly poisonous with rotten fish odor, slightly soluble in water. Its decomposition property, combustible, it burns with metallic salts, with chlorine, it forms to give phosphorus trichloride and seal. Then it is having its uses as a Holmes signal when it is mixed with calcium carbide and calcium phosphate. It reacts as fire, it catches fire and lights up burning gases. It is used as a signal if the way is lost in the water and all, so they burn this so that it lights up and they give the signal for the protection, for the help. Smoke screen, it is a calcium phosphate used as a smoke screen. So smoke screen, it is used, so calcium phosphide is used as a smoke screen. Then we have cellulose, then rat poison, zinc phosphide is used. Then we have a new compound called as orthophosphoric acid. Its preparation we have to study. The phosphorus pentoxide treated with water, then red phosphorus with nitric acid, then calcium phosphide with hydrogen sulfate, then phosphorus pentachloride with water. All these preparations we have to prepare H3PO4, that is orthophosphoric acid. Next, its physical property, it is colorless, syrupy liquid. Then how it is reacting on heating, it forms pyrophosphoric acid. Again on heating with water, it forms metaphosphoric acid. It is tribasic and ionizes in 3 steps. First step, readily it ionizes. Second, it is weakly, whereas in third step it is very weakly ionized. Then we have its uses for preparation of hydrogen bromide, hydrogen iodide in laboratory, for preparing metaphosphoric acid. Then what we have to study is next compound called as orthophosphorus acid. This orthophosphorus acid preparation we have from phosphorus pentoxide and water, phosphorus trichloride and water. Next what we have to study is its properties. Its physical properties, it crystallizes as deliquescent white solid. Acidic nature, decomposition it has. This reaction is a disproportionation reducing nature. Sulfur dioxide reacts with orthophosphorus acid. Then we have its uses. As a reducing agent it is used. Then we have a fertilizer. Fertilizers are the chemical substance which are added to soil in order to make the deficiency of nutrients required by plants. Nutrients are classified as primary nutrients, secondary nutrients and micronutrients. Type of fertilizers. Nitrogenous fertilizers, it is used as a urea, ammonium sulfate, then calcium sulfate, phosphatic fertilizers, mixed fertilizers we have. Let us move on to 16 group elements. 16 group elements are oxygen, sulfur, then we have selenium, tellurium, polonium. All these elements have their valence 6, that is they are having 6 electron in their last orbit, that is ns2 and p4 electronic configuration it is having. So we need to study its properties. It ionizes on moving down the group from oxygen to polonium. It ionizes, the ionization energy decreases because of increase in atomic size. Metallic character, on moving down the group, metallic character increases. The oxygen to polonium because decrease in ionization energy. So metallic character goes on increasing due to low ionization enthalpy. Oxidation state of 6 group elements are +2, +4 and +6 due to promotion of electron in a vacant d orbital. In vacant d orbital, here we can see the diagram. Each time one electron get excited, due to this they can have oxidation state up till +6. Allotropics of oxygen exist in 2 allotropic forms, that is O2 and O3. Sulfur exists in a number of allotropic forms such as rhombic monoclinic plastic sulfur. Selenium has 2 common forms, red non-metallic and white and grey metallic. Tellurium occurs in 2 allotropic forms, crystalline and amorphous. Polonium also exists in 2, that is both metallic. Chemical properties we need to study now. They form hydrides. Hydrides of all elements of oxygen family form stable hydrides, the type H2N, either by directly combining with hydrogen or by action of acid on metallic sulfide, selenites and tellurides. Next, their bond angles, it goes on decreasing as we move down the group. The decreasing bond dissociation enthalpy from metal hydride bond is due to increase in size. That means what? As we go down the group, the bond is weakening, so we can break the bond easily. Next, what we have to study is halides. They combine with chlorine, bromine, iodine to form different compounds, different halides. Oxides also are formed. Some important compounds of oxygen. Oxygen can be prepared in a laboratory by potassium chloride. Potassium chloride and oxygen is given out. In manufacture of liquid air, air is liquefied by making use of Joule-Thomson effect. Liquid air is a mixture of liquid nitrogen and liquid oxygen. The difference in their boiling point is about 12.8 degrees centigrade. Hence, they are easily separated by fractional evaporation. By electrolysis of water, acidified water is used. At cathode and anode, what reaction is going on is at cathode hydrogen goes. Why? Because cathode is negatively charged, and anode OH minus ion goes and gives its electron, whereas cathode it gives hydrogen takes an electron and form H2. Next, properties we should study. It is colorless, odorless, tasteless gas which is slightly soluble in water. Liquid oxygen exhibits paramagnetism. It is non-inflammable but a supporter of combustion. Next, what we have to study is bond dissociation energy is high. Therefore, it reacts with metal or a non-metal. After external heating to start the reaction, nitrogen and oxygen combines to form nitric oxide. Next, we have to study its uses. In oxyacetylene, oxyhydrogen flames, liquid O2 is used as a rocket fuel for a life support system. Example, in hospital, in water diving, or for divers, for miners and mountaineers, as an oxidizing and bleaching agent. Next, what we have to study is about ozone. Ozone is a new compound. What we have to study now, it is formed in the upper layer of atmosphere by action of ultraviolet rays from sun on oxygen. It prevents ultraviolet rays. Because of that, we all are safe. Here, what happens is CS, that is chlorofluorocarbons, common refrigerants, deplete the ozone layer. The gas coming out from the refrigerant, they go on depleting the ozone. Because of that, the ozone layer was depleted. There was a hole in the ozone layer that has been somewhat overcome by now coming pandemic days. Next is preparation. It is prepared in ozonizer by separating dry and cold dioxygen to action of silent electric discharge. Here what happens is, due to the lightning, the oxygen O2 is separated into nascent oxygen. That nascent oxygen combines with oxygen to form ozone. Let us look on to its properties now. It is pale blue gas with pungent odor. It is diamagnetic and poisonous. After 16 group, we should study 17 group now. The elements are fluorine, chlorine, bromine and iodine, and astatine. Astatine is a radioactive element. The halogens are highly reactive non-metallic elements. Fluorine is most electronegative atom and a strong oxidizing agent. Here, similar to the 16 group, what happens? There is availability of d orbital as we go down the group. Due to that, the electrons get excited in the higher energy level, and because of that, they can have oxidation state up till +7. So, oxidizing agent and their oxidizing power is in the ratio of, is in the order of F2, then O2, then Cl2, then Br2, then I2. Oxidizing power decreases as we go down the group. The reaction of iodine with water is non-spontaneous. However, iodine can be iodized by oxygen in acidic medium. Here is the reaction. It can be acidified. Next is bond dissociation enthalpy. Here what happens is, as we go down the group, bond dissociation enthalpy must be easier. That means to break fluorine should be difficult. As the atomic size is increasing, as we go down, bond dissociation enthalpy should decrease. But here there is a change, there is a variation between fluorine and chlorine. Fluorine should have higher bond dissociation enthalpy, but it is not so. Why? Because fluorine is having a smallest size. Due to smallest size, the electrons are surrounded in a smallest portion. It is called as electron cloud. Due to that, there is electron repulsion. Because of that, chlorine is having highest bond dissociation enthalpy compared to fluorine. So trend is chlorine, then bromine, then fluorine, then iodine. Fluorine shows anomalous behavior because of its very small size and highly electronegativity. F2 has a less bond enthalpy than chlorine and Br2 and the absence of d orbital in the valence shell. Next, what we have to study the element is chlorine. Chlorine can be prepared by two methods, that is a lab method and by Decon's process. Decon's process is nothing but HCl is treated with oxygen in the presence of a catalyst called as copper chloride. Chlorine is obtained by electrolysis of brine solution also. A concentrated NaCl solution is used. Chlorine is liberated at anode. Anode is a positive charge electrode where Cl minus goes and takes an electron to form Cl2. It is also obtained as a byproduct in many chemical industry. Next, we have to study its properties. It is greenish yellow gas. It is pungent and suffocating odor. It is soluble in water. Here are the properties, how it reacts with ammonia, with excess and with little of chlorine. With excess of chlorine, it forms an explosive compound, whereas with little of chlorine, it forms ammonium chloride. With the sodium hydroxide, when it is dilute and cold, it forms NaCl and sodium hypochlorite is formed, whereas with the hot and concentrated sodium hydroxide, it forms NaCl and water and sodium trichlorate has been formed. With dry slaked lime, it gives a bleaching powder. So these are all its preparation, chemical properties. Some important compounds of halogen, let us study now. It can form HCl, interhalogen compounds. It can form oxoacids of halogen and oxides can be formed. Let us study how to prepare HCl. Here, sodium chloride in laboratory preparation. Here, sodium chloride is taken and treated with hydrogen sulfide at a temperature of 420 Kelvin to form sodium hydrogen sulfate. HCl is given out. HCl gas can be dried by passing through concentrated sulfuric acid. It is a colorless and pungent smell gas. It is aqueous solution is called hydrochloric acid. When 3 parts of concentrated HCl and 1 part of concentrated HNO3 is mixed, aqua regia is formed. Aqua regia, remember, it is formation of 1 part of HNO3 and 3 parts of HCl. This is used to clean the native elements like gold, platinum. It can also form interhalogen compounds. When two different halogens react with each other, interhalogen compounds are formed. These compounds are covalent and diamagnetic in nature. Diamagnetic, all the orbitals are filled. They are volatile solids or liquid except CLF, which is gas at 298 Kelvin. Interhalogen compounds are more reactive than halogens except fluorine. Here XY3 type of compound is being formed. XY5 is also formed. Pyramidal shape, and IF7 has pentagonal bipyramidal structure. Oxoacids of halogen also we need to study. Decreasing order of their acidic nature we have. Hypofluorous acid is more than hypochlorous acid, there is more than hypobromous acid is more than hypoiodous acid. So it is a trend of acidic nature. Next we should know its structure of oxoacids of chlorine we should know. Then next what we have to study is oxides. Fluorine forms 2 oxides, OF2 and O2F2 it can form. Chlorine forms a number of oxides such as Cl2O, Cl2O3 it can form. It goes on increasing with increasing oxidation state. Next what we have to study is about ozone. Ozone is unstable. It reacts, its properties we are studying, how it reacts with potassium iodide, with water, with hydrogen sulfide. Then next its uses. It is used as a disinfectant, as a germicide. It is used as a bleaching agent for oils, ivory wax and delicate fibers, for detecting the position of double bonds, and is unsaturated compound in destroying elements of 18 group. Let us study now. These are helium, neon, argon, krypton, xenon, radon. In this, radon is a radioactive element. All these are gases and chemically unreactive. Down the group, their ionization enthalpy decreases. Therefore, xenon reacts with oxygen and fluorine and forms different compounds. Xenon and radon are the rarest element of the group. The first prepared noble gas compound is Neil Bartlett. Let us look on to its occurrence. On account of their inert nature, the noble gas always occur in the free state. Argon is most abundant noble gas in atmosphere, while radon is not present in atmosphere. Helium, argon and neon are also found as constituent of dissolved gases of certain spring waters. Let us look on to their physical properties. Their electronic configuration, they are completely filled orbitals, they are inert, but as we go down the group, ionization enthalpy decreases. As ionization enthalpy decreases, xenon is able to form the compounds. Heat of evaporation and polarizability is low. What happens here is, as we go down the group, due to increase in van der Waals force, the van der Waals force is very weak as we go down the group between the monoatomic molecules. Therefore, heat of evaporation polarizability is very low. Solubility of noble gases are slightly soluble in water, and the solubility generally increases moving down the group. Why it is increases just now we studied, because of low ionization enthalpy. As we go down the group, electrons are lost easily. Therefore, solubility increases. Adsorption. About adsorption, what we had studied, easily liquefied gases are adsorbed more, we had studied in a previous unit. Therefore, as we go down, what happens? Liquefaction of gases increases. As liquefaction of gases increases, adsorption also increases. Next, what we have to study is chemical property. These noble gases are not very reactive. Why? Because they are inert, they have completely stable electronic configuration. And these are highly ionized in energy. The electron affinity of noble gases are almost zero. Here are the compounds, how they combine, how xenon combines with fluorine compounds to form XeF2. With the increase in ratio, it can form xenon tetrafluoride. With O2F2, it can form xenon hexafluorides. Then partial hydrolysis of xenon hexafluoride we have to study, which use XeOF4 and XeO2F2. So these are all the structures of XeF2. It is linear, XeF4 is square planar, XeF6 is distorted and octahedral. Next, what we have to study is about their uses. Helium is used for metallurgical observation. It is filled in the balloon and it is used for the observation. Next, what we have to study about is a gas cooled reactor to produce powerful superconducting magnets and as a diluent for oxygen in diving apparatus. What happens here is, when a person goes deep into the sea, due to increase in water pressure, the blood is more dissolved in the cells. But when this person comes above the sea level, the pressure decreases. As pressure decreases, blood from the vessels, cells want to come out fast, they ooze fast. Because of that, a person may have a disease called as bends. So to avoid this, helium is mixed with nitrogen. This is one of the application of helium. Argon is used in filling bulbs to produce inert atmosphere in various metallurgical operations. Also, neon is used in discharge tubes. What we can see, advertisements, large screens at night, it will be glowing, these screens will be glowing. These all are added by the neon gases. So this was all about the P block elements.